x plus y is equal to 8. How are we going to find the answers for x and y? We don't even know any of them. This case always ends up giving you double answers. One answer for x and another answer for y. For question 1, the condition attached is that x and y are positive whole numbers. They must be positive numbers, no negative answer. Alright, in order for us to do that, we start as an assumption. First, let's assume that x is 0. So let's say if x is equal to 0, what will be y? If we're fixing the value of x as 0 here, it means that y is equal to 8. So when x is 0, y is equal to 8. Done for the first part. So x can be 0, y can be 8. Both of them are positive numbers. Yeah? Next one. What if x was not 0? What if we make x to be 1? What's going to happen to y? 1 plus what will give you 8? 1 plus 7 will give you 8. So in that case, y will be equal to 7. We have also found the two answers. So when x is 1, y will be 7. Is that all? Let's see, there are more answers. What if x becomes 3? What happens to y in that case? If x becomes 3, for us to get the answer 8, y is going to be 5. So when x is 3, y is 5. We are done. Easy. What about a situation whereby x becomes 4? You notice that 4 plus 4 is 8. So when x is 4, y will also be 4. Done also. But that's not all. We can go a little further. Now, give x the value of 5. When x is 5, what happens to y? 5 plus 3 is 8. So in that case, y is going to be 3. What if x becomes 6? What happens to y? Y is going to become 6 plus 2 is 8. Does it end there? What if x changes to 7? In that case, y is not going to be 2 anymore, but y changes to 1 because 7 plus 1 is 8. So y changes to 1. And also, what if x takes the whole value, 8? What happens to y? It means that y is 0. Did you see here that we have so many pairs of values that can take the place of x and y? How many pairs do we have? 1, 2, 3, 4, 5, 6, 7, 8. For the condition given, we have 8 different pairs of answers that are correct. For question number 2, y minus z is equal to 11. But what is the condition? The condition here is that y is a positive prime number and z is not equal to 0. It means that z can never be 0. And at the same time, y can never be 0 because y is a positive prime number. To help us visualize exactly what this is going to be, we can first of all list down the prime numbers we know that y can take, because y must be a prime number and must be positive. Therefore, let's list down a few prime numbers we know. Let's begin with the number 2. 2 is a prime number, yeah? So the prime numbers we know are 2 is there, 3, 5, 7, 11 is part of them. Let's stop here for now. Now, among these numbers, is there any of them that y cannot take? We will find out when we start solving the problem. So let's first assume that y takes the value 2. If y takes the value 2, remember that z cannot be equal to 0 and y cannot be negative. So if y takes the value 2, what can z take? Because z is already negative. Let's think about it. If y takes the value of 2, how can we operate this so that we get the answer 11? If you remember your operation earlier, where we said that negative multiplied by negative is going to give us positive, that will help us in this case. So we can say when y is equal to 2, this condition will now become 2 minus z is equal to 11. Watch. With your scale of equation, which we just solved not long ago, I can choose to take this 2 to the right hand side. And to do that, I will need to minus 2. So if I minus 2 from this side, minus 2 from this side, I'll minus 2 from this side also. Yeah? In that case, 2 and 2 will cancel out. But you have negative z is equal to, so let me write it out. Negative z, this is negative 1z, don't forget that, is equal to 11 minus 2 is 9. It does not end there because this is negative 1z. So it means I can divide by negative 1 and negative 1. So if negative 1 divides negative 1, it means that z will be equal to 9 divided by negative 1 is negative 9. So it means that when y is 2, our z is going to be negative 9. I'll write it down. When y is 2, our z is going to be equal to negative 9. Let's pen it down. We don't want to forget that. When y is 2, our z is negative 9. This is the first pair we have just generated. Now let's try the second number. What if y becomes 3? What happens? So the simple way to be getting your answer this time around is this. Let me tell you a simple trick. Whatever answer you get here, subtract 11 from it. That will give you the answer for z. Let's test the first situation to show you how I got it. Y was 2. So 2 was here. 2 minus 11 is negative 9. Did you see that? So anything you get as a value of y, just minus 11 from it, you get the answer for z. Good job. So let's proceed. When y is 2, z is negative 9. Let's check the next value. When y becomes 3, what will be z? 3 minus 11 will give you negative 8. So z will be negative 8. Done. Next value, 5. When y is 5, what will be z? 5 minus 11 will give you negative 6. So z will be negative 6. When y takes 7, when y is equal to 7, z will be equal to 7 minus 11 will give you negative 4. Remember, z can take any value but not 0. So let's keep going. We've gotten this level. Next, y takes the value 11. When y takes the value 11, what happens to z? 11 minus 11 will be 0. We can take that. Now for the second example, we have h times j is equal to 16. The rule here is that j and h are whole numbers. J must all the time be greater than h. Notice that this is multiplication. It means two numbers must be multiplied together to give you the answer 16. And the rule is that j must always be greater than h. Now, one thing that can help us is to find all two numbers that you can multiply together to give you the answer 16. The two numbers can be 1 times 16, 2 times 8, and the only other one would have been 4 times 4. But we cannot work with 4 times 4 because of this condition, which says that j must be more than h. Here, both of them are equal, so we're not going to work with it. In that case, notice, for the first part, 1 is less than 16. For the second part, 2 is less than 8. So you can easily partition them like this by saying that h times j equal to 16 can appear in the same way. Since j is small, the first one is 1 times 16, where j is 16 and h is 1. So it means that j is equal to 16 when h is equal to 1. This is one condition. The second condition is 2 times 8 is also equal to 16. So meaning that in this case, since j must be more than h all the time, j will be 8 when h is equal to 2. Negative numbers can also work this out. But in terms of negative number, let me give an example. For instance, we can deal with negative 2 times negative 8. This will give us positive 16 also. And in a situation like this, the bigger number is negative 2. So in this case, j will be negative 2, while h will be negative 8.